This is a chemical demonstration of a comparison of the specific gravities of several chemicals and their relative solubility in water. Understanding a chemical's physical properties when it is spilled to water will help responders to understand its behavior in the water and help direct their actions to mitigate a release. Two major physical properties of a chemical to reference are solubility, also known as miscibility, and specific gravity. First, let's look at the definitions. Solubility or miscibility is the ability of a solid, liquid, gas, or vapor to dissolve in water or other specified medium. Solubility is measured in percentage. If a chemical will not dissolve into water, it is said to be insoluble or immiscible. If a chemical dissolves completely into water, it is said to be 100% soluble or miscible. Specific gravity is the weight of a material as compared with the weight of an equal volume of water. If the specific gravity is less than 1, the material is lighter than water and will float. If the specific gravity is greater than 1, the material is heavier than the water and will sink. The chemicals we will use in this demonstration are water as our standard, which will be colored with red food coloring for contrast, paraffin oil, mineral oil, and glycerin. The first step is to take 10 milliliters of water and pour into our glass vial. We will then add 1 drop of red food coloring to where we can see the contrast in comparison to the other materials we will add. The red food coloring has completely dissolved into the water, and we can say that that is 100% soluble. Also, the specific gravity of water is equal to 1. Next, we will add 10 milliliters of blue paraffin oil to the glass vial so we can compare the solubility and specific gravity of the chemical to water. As you can see, the blue paraffin oil has been added to the vial and it does not appear to be dissolving into water, therefore it is insoluble. You can also tell that the blue paraffin oil is floating on top. The paraffin oil specific gravity is 0.77, which in comparison to water makes it lighter than the water. Now we will add 10 milliliters of mineral oil to the glass vial that already has the water and the paraffin oil in it. The mineral oil we added is the clear layer above the red water and below the blue paraffin oil. As you can see, the mineral oil is not soluble with the water. The mineral oil specific gravity of 0.84 makes it lighter than the water, but still heavier than the blue oil. Now we will add 10 milliliters of glycerin to the glass vial. The glycerin is the clear layer on the bottom of the vial. The glycerin appears to be insoluble in the water, but actually it is 100% soluble or miscible. Due to the glycerin's weight or specific gravity, it sinks to the bottom too fast to allow it to mix with the water. The solubility of glycerin is 100% and its specific gravity is 1.26. To conclude, the solubility and specific gravity of a chemical can tell responders where to look for that chemical when they are released to water and the extent of the release. They can then select techniques to recover a chemical from water, such as a floating sorbent boom or vacuuming contaminants from the bottom of a body of water.